Hello guys, welcome to my channel. Today's video is about stack implementation using a linked list. This is the Java data structure and algorithm tutorials. You can learn different data structures and algorithms using my videos. Thank you. And if you have not subscribed to my channel, please subscribe and encourage the content. Stack basics. Stack is a linear data structure. Stack is a LIFO, last in first out, or FILO, first in last out data structure. Operations of push and pop occur only on one end of the stack. Usage: infix to postfix conversions. We use the stack to convert an infix mathematical expression to postfix conversion so that we can evaluate it. Use the undo mechanism and store the commands that we want to undo in a function in an application. Operations are methods I am going to implement for linked base stack implementation. Push function, push an element at the top of the stack. Pop or remove an element from the top of the stack. Peek, look at the top element of the stack. isEmpty, check if the stack is empty. Print the stack to see its state. And size, the total number of elements stored in the stack. Stack complexity. Stack complexity is very important. Push function, the complexity of the push function is O1 if stored at the beginning of the list. The complexity is On if the element is stored at the end of the list. We can improve this On by adding a new feature, new pointer, tail in the list implementation. The tail pointer can be used to push new element at the top of the stack and the complexity will be O1. In case of pop, the complexity of the pop function is O1 if removed from the beginning of the list. In case removed from the end of the linked list, complexity will be On, or you have to add another pointer for the tail to achieve the O1 complexity. Peek, if stored at the front of the list, peek is O1. If stored at the end of the list, peek complexity is On, or add another pointer tail to achieve On complexity. So in this implementation, I am going to use front of the list to be used for the push, pop and peek functions. Space complexity is On, where n is the number of elements in the array. Array is not used in the linked list. Thank you. Let's code. Hello guys, I have created NetBeans project for implementation of linked stack. This is the tester class. This is how we will proceed. Create an object for the linked stack. Create a random object to create or generate random numbers. We push five numbers randomly generated and display the state of the linked stack so that we can confirm the implementation is working correctly. Then we will test the pop function. Inside these loops, we are going to number one, push here, check size and peek the top element and print the stack. Similarly, we will run this loop till the stack is empty. We will print size of the stack. We will check the top element of the stack and then we will pop the stack element and print it and then print the list. I am going to use the node class from the linked list, singly linked list. This is a single linked node class that we will use to implement the linked stack. This is just like a linked list, but we will add and remove the elements from the front of the linked list. So two elements, two data fields, number one data and number two is the next pointer. Next pointer will point to the next element of the node. Constructor and then we have the setter and getter functions for the data and next pointer. And this node constructor is taking data as a parameter and store it. This is linked stack, this is empty. I just created a skeleton of the methods and I am going to implement it so that you can learn how to implement a linked list based stack. Top of stack. In linked list we used to have a head of the stack, head of the linked list. Here we will have private node top, taxonomy of stacks. So create it. Let's add another variable, private int count the elements in stack, store linked nodes of data. So top is equal to null and count is equal to 0, just like we did in the singly linked list. Okay, now let's add smaller methods. Simply return count, and we don't need this function because it is array based requirement. And here we will return top is equal to null, means the application is, this stack is empty. Okay, print stack node current is equal to top while let's put a condition to check if it is empty. If this dot is empty, we simply print stack is empty and we return. And this we navigate to the end of the stack is not equal to null, and we print it as out and percentage minus 10d and current dot get data and navigate. Current is equal to current dot next. Okay, this function is good to go. Let's print a new line, and this will display the elements of the stack. Start from left to right because we are storing the elements at the top of the stack from the front. Okay, if not, this dot is empty. Return top dot get data. Otherwise, throw new illegal argument exception. Stack is empty. Okay, now come here. Here we will add to the top. So create a node, new node is equal to new node, and we need a we need to remove. Okay, if this dot is empty, as out, let's throw an exception. Stack is empty and in return do nothing. Otherwise, let's say -1, or we can throw exception, whatever your choice is. So here we will just assign next node to top. Top is equal to top dot get next. That's it. We have to do nothing because garbage collection, Java garbage collection is automatic. In C++, we need to delete the dynamically allocated memory. Okay, here we create new node. Node is equal to new node and value. Okay, if it is empty stack, if this dot is empty, so we simply store new node to the top and increase the count. Else, now this is what we have to do. Top dot node dot next is equal to top, and top is equal to node. Okay, so node dot set next is equal to top, and top is equal to node, and count plus plus. That's it. And we can remove here count minus minus, reduce the number of elements. Okay, our stack implementation is complete. Let's see if there is any error. One error. Okay, we need to return the number. Int element is equal to top dot get data, and we return it. Return element. Okay, let's test it. And test it. Let's see what is happening. Okay, we generated 27, pushed it on stack, element size 1, top element 27, and it is stored here. Then we generated 62, pushed it, stack element, stack number of elements 2, top element 62, and it is pushed here. Same way 83 pushed here, 4 pushed here, and 19 pushed here. Now we started popping elements from top of the stack. This is current size and top element. We removed it. It is removed, and we left with this stack elements. Same way, removed 4, and we left with these. So our stack, linked stack, is working perfectly. That is how you can implement a linked stack and learn how to implement different data structures. There are a lot of data structures available to be implemented in Java, and this will help you enhance your programming skill. Thank you guys. Have a very good day, and if you have not subscribed, please subscribe to my channel and promote the content. Thank you. See you in the next video.